In the vastness of the solar system, the gas giant Jupiter looms like a titan. Colossal, chaotic, yet endlessly captivating. This massive planet has been visited so far by 9 spacecraft, revealing a world of titanic storms and magnetic fury. And although the orbiting Galileo spacecraft came to a fiery end when it was deliberately sent plunging into Jupiter at the end of its mission in 2003, only once have we sent a probe into the gas giant, attempting to find out what lies below the clouds. In 1995, a small bullet-shaped probe, simply named the Galileo Atmospheric probe, dove into Jupiter. It was the first and so far only time we physically explored the inside of a gas giant planet, studying Jupiter's cloud layers as it swallowed our machine whole. But how long did the probe last? And what happened to it once we lost contact? You're watching V101 Space. My name's Rob, and if you enjoy diving into the wonders of space, don't forget to subscribe for much more to come. After the incredible success of the famous Pioneer and Voyager missions of the 70s and 80s, NASA designed a follow-up mission to study Jupiter. This was the Galileo mission. The mission achieved many firsts, including being the first spacecraft to orbit an outer planet, the first to fly by and image an asteroid, and the first to observe a comet collide with a planet, when comet Shoemaker-Levy 9 broke apart and crashed into Jupiter. But it was also the first to deploy a probe into an outer planet's atmosphere. The Galileo Atmospheric probe was no ordinary machine. It was small, just over a meter across, but it was a masterpiece of engineering. Built for one task and one task only, to survive as long as possible when no machine has ever explored before. It consisted of 2 parts. First, the deceleration module, a rugged, heat-shielded shell designed to withstand the violent transition from the icy vacuum of space to the searing chaos of Jupiter's upper atmosphere. It would face hypersonic speeds, crushing shockwaves, and temperatures hot enough to vaporize metal. Inside it, protected like a precious seed, was the descent module. This was the heart of the probe. Packed with sensors and scientific instruments, it would detach once the worst of the entry was over. A parachute would deploy, gently slowing its fall, giving the probe precious minutes to study its new environment. Launched in 1989 aboard the space shuttle Atlantis, the Galileo Atmospheric probe was a passenger attached to the Galileo orbiter on a 6-year odyssey through the solar system. It took a complex path, looping past Venus and Earth to gather speed, a cosmic slingshot that eventually hurled it toward the king of the planets. For 3.7 billion kilometers, the probe slept, nestled within the orbiter. As it approached Jupiter in July 1995, the orbiter released the probe, set on a collision course with the giant ahead. What followed would be one of the most dramatic and least known episodes in the history of space exploration. The small probe hurtled through the inky black void, detecting nothing but the deafening silence of space, contrasting sharply with the turbulent storms that awaited it. It entered the Jovian atmosphere in December 1995 at an incredible speed of over 170,000 kilometers per hour, fast enough to jet from Los Angeles to New York in just 90 seconds. It endured extreme heat as it slammed into Jupiter, as friction ignited the air ahead of it. The heat shield began to vaporize, losing around 60% of its mass as it carried away the inferno in front of it. The incandescent shockwave ahead of the probe was as bright as the sun, reaching searing temperatures above 15,000 degrees Celsius. Then, an explosion. The sound of a mortar as the drogue parachute deployed. Explosive bolts were fired, releasing a cover which in turn pulled out the main parachute. This entire process was designed to take less than a few seconds. With the billowing fabric above slowing it down, at maximum deceleration, the probe endured a force of 228 Gs. The average human body can only withstand up to 6 Gs. Now the probe was ready. Its sensors are activated, and it began to transmit information about its new, bizarre environment. For 61 breathless minutes, the probe's transmitter returned valuable data. Its instruments revealed a world far stranger than scientists imagined. Data indicated an intense radiation belt about 50,000 kilometers above Jupiter's clouds. Few organic compounds were found, and howling winds blew at speeds of about 640 meters per second. The entry probe also found less lightning, less water vapor, and half the helium that had been expected in the upper atmosphere. Each reading defied expectations. Each byte of data rewrote what scientists thought they knew about Jupiter. Then, silence. The probe's transmitter failed. Although the probe's equipment and electronics were designed to survive up to around 20 atmospheres of pressure and temperatures of around 200 degrees Celsius, communication was lost at about 23 atmospheres, about 180 kilometers below the entry clouds. At that depth, it would have been the equivalent of being roughly 220 meters deep in Earth's ocean. Mix those crushing pressures with a scorching temperature of 150 degrees Celsius that is continually climbing, however, and the probe was on borrowed time. But importantly, it still transmitted data right up to the bitter end, giving us everything it could in its brief, heroic plunge. The question of what happened next is easy to answer. The Galileo Atmospheric probe fell deeper and deeper until eventually it was crushed, vaporized, and then lost forever. No explosion, no wreckage. It became a part of Jupiter's atmosphere. It completed its mission. It had successfully done in around an hour what nothing had ever done before it. No other probe has ever followed. The Juno spacecraft has been orbiting Jupiter since 2016 but stays safely far above the clouds. En route to the King of the Planets are the next generation of spacecraft, the upcoming JUICE and Europa Clipper missions, but like Juno, they will also study from above. And there has been some talk of sending a probe into Neptune's atmosphere in the coming decades. However, nothing has been planned as of yet. Still, the dream persists of one day sending a new probe, smarter, tougher, deeper, to dive once again into the colossal unknown, to follow where the Galileo probe dared go, and perhaps to go even further. I hope you enjoyed this video. If you did, then remember to like and subscribe for much more to come. And if you would like to support my channel even further, then why not buy me a coffee?
A small donation goes a long way and helps me improve what I am attempting to build. Thank you for watching, and I'll see you next time.